color image, grayscale image. That is first step. Camera captures the color image. Then you convert the color image into grayscale, which is nothing but black and white image. You don't say black and white, technically it should be called grayscale, because black and white means black is represented by one particular value, white is represented by one particular value. In between you have grayscale, right? Starting, we'll show that. If it is only two things, it's called a binary image. Binary image cannot differentiate different shades of picture, right? So convert. So for that you use color to grayscale conversion algorithms. We'll use color to grayscale conversion. Then apart from that, this image what you are capturing may contain a lot of noise, right? It can contain a lot of noise. That how to remove that? For that you use noise filters. Please note that all these steps are many of them can be implemented using algorithms, software algorithms, correct? Which can be run in a computer. So that means you write in C, Python, or some other any other software which is convenient, C++. Those algorithms will do all this process. The next thing is called edge detection. Then from edges you can construct lines, correct? Lines represent the border of the object, correct? Any object as a border, that thing, the line can be a straight line or a curved line, or it can be a spline, correct? We will see that. So the lines are used for bounding an object, bounding the object, right? If I say that I am representing a human, something like this, easy. So you know that it is nothing but a circle. That is nothing but it represents head, correct? Head is represented by a circle. This line is what called as a construction. The line contains infinite number of dots. That is called edges. The dots are, for example, understand by say it is called edges. Individual dot is called one edge. So if I connect the edges, I will get a line. So that's what first we will direct edge, then connect the edges, then you will get the line. By connecting many lines, you will get the object, correct? Constructing. So for example, lane marking direction. Please note the lane marking is generally we say that it is like something like this, right? It has, for example, 1.5 inch, correct? So this may be say 20 inches, but I don't know. It is painted with white. So this is an edge, correct? It has an area, correct? This has 20 inches length and 1.5 inch width, fully painted with this one. So it has some length, it has some width, correct? Within that, it is completely filled with white color. So if I want to deduct the lane marking from the picture, this picture, what I do, I need to find these edges. We say border, right? Border or bounding line, all this thing you can use, which is enclosing the object, total object. So for that we could then finally many times the image may be distorted, right? Which is called as perspective. This already we talked about it, right? When you see two straight lines at this one, when I convert 3D object in 2D, it becomes perspective. They parallel line look like they are merging at a far away end, vanishing point. So that should be corrected. Then once the edges are detected, lines are detected, then identify the your lane marking. What I am showing is the MTech project. Some 7-8 years before, one student, I told you I am working on USR lab. One student was working, developing this algorithm, image processing to detect the lane marking. So what he did in the lab, you took a yellow color tape. This is my lab surface, this one inside my lab. You can see that already it has a different color, multicolored flooring on which you put a yellow color tape, correct? Which is 1.5 inch thick and maybe something around 5 meter length, correct? He stuck on the floor. Then he captured this image using a color camera. Then he converted grayscale. He did noise reduction, edge detection, line construction, perspective, this one. And finally, he was able to detect. Which detected lane marking is shown as green color. This is what you have to do. if you want to do lane marking. So these are different steps. Capturing image using camera, correct? Then if you don't want color information, immediately convert to grayscale. So the computational burden reduces, correct? Computational burden reduces. Then all the process are done using grayscale image. So my CPU computation, but please note that you may think what is big in it. You are making 1 million car, right? One NVIDIA, if you add even this one, in NVIDIA itself, there are different speed, right? Operating speed, all cost varies. Even if you save $5, you save $1, right? 1 million, 10 million means $10 million is reduced, saved, right? So cost is very important in company. Engineer tell all of you know your company. Cost cutting, reduction, right? Otherwise you cannot compete your competitor, all those things. So these are steps we are going to see now. First thing is converting the color image into black and white or a grayscale image. Okay. So please see that this is a picture. Please, many of the pictures I have taken from internet. That is not my picture, but I always use for teaching. Okay. So you can see that they took a photo of a rose in the garden. This rose is in the foreground, right? And the background you can see another flower, which is on violet color. There is a leaf, something, all these things are there. So this is a colors picture that is converted to grayscale picture. We call it black and white picture. To do so now we know that the colors are nothing but electromagnetic waves. So we say the wavelength is always lambda. So normal wavelength of the color, we start with ultraviolet color to infrared. Ultraviolet, infrared are not visible, bordering. Visible is, we know that V to R, right? With GR, we always call violet, indigo, blue, green, yellow, red, right? So now, if we can see here the color picture contained all this information. Ultraviolet is 400 nanometers, correct? Please represent 400 nanometers. That is nothing but 10 power minus 9 meter. That is wavelength, correct? So infrared is 750, but our visible is between this, correct? Something around 400, 420 onwards. That is violet to red. Okay. Now, if our interest is, I told you that if it's a color camera, it has in a pixel. If I say color camera, one pixel represents 3 dots. One dot is green, other one is red, other one is blue. This is 1 pixel in color camera. That means there are 3 photo transistors. Okay. If I say that my camera is, say, 800 by 420, right? That means this multiplied by 3, this multiplied by 3. Correct? Now you know that the image size, which is called number of pixels, number of megapixel increases. So by converting, I can reduce 3 times less volume. Data can be reduced. Okay. Now, if I convert the violet color into grayscale, it will, please notice this is black, right? This is black, pure black. Okay. Violet color will become slightly, you can see it. It is not, still looks black, but it's not a real black. Then if I take this region, each region is shown here. You can see here. Right? If I take this blue will become like this. Depending upon, see, blue is a different range. Dark blue, light blue, like this. This is light blue. This is dark blue. Correct? This is mix of blue and green. This is the green. This is yellow. This is mix. Correct? Yellow and red mix. Red is a different variant shades. Correct? We say they call palette. Correct? Color palette. We call it a color palette. Correct? Color palette, you can 256 color. That is low. Correct? Up to million color, 1 million colors. right? Please note that the color reception capillary individuals are different. Already last week I told you there are people, sorry to say, that they can't see colors. They call color blind by birth itself, right? They can't see any color. What they will see is only this. If they see these rows, for you, you'll get a violet color, all this thing, they will see only this. Please note that many animals, including cow, all this thing, color blind. Please know that they are color blind. Many animals.
So human also same thing, sir.
Pardon?
Human also having the same disease, sir.
Some people get disease. Color blind you will see very rare. It is very rare. They can't see color at all. They will see only this black and white picture. Anything will be black and white picture with the grayscale picture only. But many animals by birth, see, color blind is rare phenomena. Humans, very few, 1 in million, 1 in 10 million maybe color blind. But animals, generally they are color blind. They don't have color vision at all. Many animals, whatever you see, big animals, cow, anything, elephant, something, all these things, they don't. Exactly, I don't know, but many of the animals are they can see only grayscale image, not color image. They are color blind. But they eat, sense all those things using smell. Many of things they have very good smell. From that they are differentiated objects. But exactly you have to find. But there are animals with this one. That's not this one. But that's okay. Fine. Now I want to convert my color image to black. This one grayscale. If I convert my color, I will get this. Okay. Conventional color with grayscale includes salient feature and is a complicated and time-consuming process, computationally expensive. Correct? Doing this is a computationally expensive process, right? But for example, inspection system in factory, correct? Where color is, you can install black and white camera or monochrome camera. Color is not needed, correct? So, see, if you are a design engineer, you are going to inspect some object where color is not important. Only grayscale image sufficient. You don't use color camera, correct? So color camera become expensive. So you can save the price of the system. Color camera, say 1,000 rupees, low cost. The grayscale camera make 200, 300 rupees. I'm just saying. Okay. But if it is needed, you have to use color, then use the. Sometimes you need, correct? Color, but you can remove the color by conversion. Convert a grayscale image may lose contrast, sharpness, shadow, structure, and color information. Correct? So this is color information. Correct? Different level of cover, the shorten, all those things. If I convert, all these things can happen in the grayscale image. But no other option, because suppose you need to convert into grayscale, that is best for your operation. Color information or little bit sharpness reduction. All these things will happen when you convert. Anything convert one to another form, always there will be some amount of loss of information. That is acceptable, you can do that. Many times you can do it. Correct? Preserving the basic contrast, sharpness, shadow of the structure of the color is very important, so that the original image attribute like object size, shape, all these things are preserved. So you have to take care while doing the image conversion, color to grayscale image. Okay. Now, when we talk about color conversion color image to grayscale image, a pixel in a color image, correct, is a combination of 3 basic colors. Please note that we say WebGR, white light contains predominantly 7 colors, which is coming from sun, or you can create your own white light, which is this one. But you can create any other colors by using basic colors, which is called red, green, blue. Okay. Then, which is always represent RGB, red, green, blue, short form is RGB. The RGB color values are represented by 3 dimensions, X, Y, Z, and illustrated by attributes called lightness, chroma, and hue. Correct? This X represent lightness, Y represent chroma, Z represent hue. RGB can be further represented by X, Y, Z scale, where one is called lightness, other one is chroma, other one is for hue. So this is called palette. I told you, this is the palette. You can see that. Right? This palette Here you have blue, here you have red, here you have green. Green is 530 nanometer, violet is 460, that is blue, dark blue, 630 is the red. By mixing, you get all other colors. This is a different proportion, correct? So each area represents a different proportion of these colors. But if you mix it, you can get any other color which is this possible. This is called color palette. Okay. The tri-stimulus values. Tri means three, stimulus. Please know that in eye also, I told you you have cells called cones and rods. We are going to see next slide. One type of cells are responsible for seeing color. Other one is for seeing grayscale, that is black and white. If you are colorblind, those cells responsible for seeing color will not be there in your eyes, retina. That's why you are not able to see the colors. Right? So, tri-stimulus, that means from the picture, if the primary colors, which are called primary colors here, RGB, comes and hit your retina, the appropriate cells, which is can generate electrical signal proportional to red color, electrical signal proportional to intensity of blue color, electrical signal proportional intensity of green color, generate electrical signal, correct? That signal goes to brain. Brain interprets by mixing this. By adding these three values, it finds what is the actual color, right? So, they're called stimulus. Stimulus means generating electrical signal. In eye, it is happening. In your camera, the photo cells generates. You have 3 photo cells. One cell, in color camera, one cell will respond only to red color. Depending on that intensity of red color, it will generate electrical signal. Other cell will drop, that will generate signal proportional to blue, other one green. All three will be going to your CPU, camera CPU. There it is mixed and it finds what is color. Okay. 3 color spaces, we call it this one. And 3 primary color, trichromatic. Tri means 3, chromatic means color. It is the Greek. Correct? So that was RGB, that's what it is. Okay. So there are international standard called CAE 1931. This is here. CAE is a French, this one. Correct? Short form of the French, this one. This is called IS, we call the ISO, similar to that. Okay. RGB is color space into CAE 1931, XYZ color space. They say RGB is color space or CAE 1931 XYZ color space. These are 2 different schemes adopted internationally to represent color image. They may have RGB color space or XYZ color space. Correct? CAE 131 RGB. These are 2 better. Just know it, what it is, will see. Okay. These 2 can be, if the image is represented using this color space, you can convert to this, or from here you can convert here. Both are possible. They are given how to convert. Okay. What do you need? RGB value or XYZ value. If you know, these are 3 information. If you have this, from here you can convert here, or from here you can convert here. Both are possible. That's what we are trying to say. Okay. Now coming back here, in human, a main thing is I told you, in the world, whatever you see, everything in a rocket, whatever you say, you get ideas by seeing nature. I told you bio-inspired robotic, another area which is fast coming for last 2 years. Correct? Making robots like a snake, a bird, they are much more energy efficient. Flopping wing aircrafts, many things they are trying. Correct? There is a separate darshan we'll see later. If we find time, that's not our part of the course, we'll see. No, what I say is human eye, correct? Camera also, color camera, whatever you see is also is duplication of human eye only. They saw the what internal structure, human eye, retina, under microscope. They saw the cones, rods, all those things. Did research for many last 100 years. Based on it, they invented the color camera, all those things. Okay. So human eye, normal vision has 3 kinds of cones. Cone cells are responsible for color. I told you, correct? Cone cell. The shape of the cell is like a cone. Please note that the size may be micrometer, 5 micrometer, correct? The diameter can be 1 or 0.5 micrometer to 0.2. That is what size. I told you in your retina, measuring few mm, correct? Say, for example, this is 5 mm, this may be 4 mm something. How many are there? 40 into 10 power 6 cones and rods. So how small it will be, you can see that. But the shape is like when under a microscope, electron microscope, you can see it. The cone cells will look like a cone, correct? Ice cream cone, that's like a cone, correct? The other one is called rods. They look like a rods, cylindrical, solid rods. The rods are responsible for black and white image. Cones are responsible for getting color about the information. If these cones are defective in your eye, you will become a color blind. That's what I told you. Still, you can see black and white. Color you cannot see. Okay, that is one thing. The next thing is the cones also. There are 3 types of cone cell. One is called red color cone cell, blue color, green color. That means there will be 3 cones close to each other. Something like this. RGB. This together forms 1 pixel. Nearby there will be a rod also. Like this, 40 into 10 power 6 minimal. It can go up to 120 into 10 power 6. This is 1. High resolution. There are people with very high spatial resolution. They can see very small. Right? They have 10 power 6 pixels in this small area of the retina. That's what we are trying to do that. Right? So now, that's one thing. So they are called as S. Right? So having a peak spectral sensitivity, which is called this one S, 420 to 440 nanometer. Other one is called middle. That is called S color code cells. S color code cells are responsible for seeing blue color information. S color cone, S cones. They called. That's what they classified. Already classified. Why they gave S? Somebody gave. You can't change it. Internationally accepted. Okay. S color S cones can see light which is in blue, 420 nanometer for this one. M type cones can see green color, 530 to 540 nano. Right? L is called long. That is for red color. It can see the red color information. So you have so this was shown here. So this is 400 nanometer to 700. 700 nanometer is nothing but red, correct? We say the infrared, IR. This is ultraviolet, UV, right? 400. So you can see that this is blue. 450 nanometer is peak, blue. This is blue color. This is S color, S type cone cells. M, you can see the green. 550 nanometer. That is a dark green. That is called M color cones. But you can see that it is something like a Gaussian, right? So this range is green. We say that this range we call it blue. This range we call it red, right? So this is how. This, after seeing a lot of research, this is how most of the human eye inside the cone cells are responding. They are called S, M, L type cells. L type cells with this one. Okay. Now, they are called SML, indicate the 3-dimensional color space, LMS color space. They call it LMS color space. This is what they use based on human height. Okay. The basic color image is generally represented 8-bit. Each color is represented by 8-bit value, binary value. In digital camera, the color value is represented 0 to 255. Correct? That means 8 bits. Binary value 8 zeros is nothing but 0. Correct? 111. All the bits are 118, 255. This is for represent red color. Similarly, same thing. 000 to 111 for blue color. Green color also 000. So 0 to 255, 0 to 255, 0 to 255. RGB. In your camera, this is how it is represented. Correct? If red color is not there, R value will become 0. Correct? If particular pixel light coming and hitting I told you there are 3 cells, light comes and hits. If it is a red color, correct, this will become 255, correct? This will be, blue will be 0, correct? And green will be 0, correct? Instead of that, if the blue color comes, this will become 0, blue will become 255, this will be 0. In between value comes, accordingly that will happen. Okay, that's what I'm saying. The color information in most of the cameras is 0 to 255. That's what is mentioned here. Basic color is 8 bits. The high color image represented using, suppose if you want still more color information, instead of using 8-bit, you can use 16-bit also. Each color represents 16-bit, correct? Then if you go and see your color setting in your display, you can set your color, no? Palette, correct? You 8-bit resolution color, you can say true color is 24-bit. That means R will be represented by 24 bits, B will be represented by 24 bits, and G also represented 24 bits, correct? To represent total color, how many bits? Totally 64, 24 plus 24 plus 24. So too much data. If I want true color, we say 1 million palette, higher the palette, higher the color information, this one, the computational intensity increases. But the picture will be good. You will be able to see many shades. Colors, we say the color shades. Correct? More number of shades you can see if your each color represents higher number of bits. 16-bit color information we use, you will get more shades. 24 bits still better, but computational intensity increases. So you have to design, right? Whether you need that much color. Right? That's why the cost of the camera changes. I told you, right? Color of this one also changes based on this one. Okay. Now, if Y, X, Y, Z information is given, correct? Already we saw in the previous page, correct? If this is what I told you, if the color information given is Y, X, Z space, X equal to this, Y equal to this one, how to convert into other color, RGB or RGB. So this is conversion formula. Note down this. This is already internationally accepted formula. I have RGB value, R equal to, for example, R equal to, I'm using 8-bit value, 100, G equal to, say, 150, and blue B equal to, say, 200. I want, what is Y? YZ skip space, because there are two color space, I told you, XYZ space and RGB space. Only two internationally accepted. Data, what I have is RGB value. I want, what is the XYZ space value equivalent? Then I have to use this conversion formula. Note down this. So this is already fixed. This is also fixed. Please see this value is internationally accepted, this value. This value multiply, if you give this, you do this matrix manipulation, you will get XYZ value. No, if you want to reverse, so you have XYZ you want to miss, accordingly you have to do that. You keep this, this will bring here, this will go here, then accordingly formula changes. Using that you can find out. Okay.
Sir, 1 minute, sir. We are noting.
Yeah, please, please.
Sir, okay, sir. We noted on.
Okay. So how to convert, correct? So here we are talking what is this color space, what are different representation color. You can represent color in the XY or RGB. Still you are talking what is the color information, how the eye senses, what is inside your color camera,